Hi, I'm Brian Corbridge, and this is the third lab of Physics 2211 about black holes. For starters, our goal for this lab is to study black holes and learn how to set up equations to solve for certain unknowns regarding black holes and, orbital planets. Um, for the sake of this experiment, part one at least, our system will be the star and the surroundings will be the black hole. For part two, the system will be the spaceship, but we'll get to that later. For this first part, we're tasked with finding the mass of the black hole as well as all the net forces placing on the star. Below are the main equations we're going to be using to find F parallel and F perpendicular. These are essential for finding the overall net force. Here we have a code walkthrough so I can show you guys how to set up my equations. For starters, delta T, that's gonna be seconds in a day, and then the star mass was already given. And this might be a little confusing, but if we're following the code in order, it will be this picture, then this picture, then this picture. So move on to here. Here, we find the initial positions and final positions. Here we find delta V and so delta velocity and delta position. So change velocity, change position. Um, Here we had change in momentum, net force. Um, he had so the unit vector, all of this, and F net is obviously, as we already established, the derivative of momentum, and then yeah, to find the perpendicular, you do F net minus F net parallel. Yeah, so we're just manipulating the equations that I had already previously shown you. It's nothing too special. And here are the arrows to set up uh, the forces for the representation on the next slide that you'll see. As you can see here are the results. Here's the mass of the black hole. Here's F net, F perpendicular, F parallel. Yeah, so that's all right there. And now we go on to part two. So our objective for part two is to have a successful takeoff, which means our spaceship goes off the planet, doesn't hit the planet again, and also doesn't get sucked up into the black hole. However, we do want to get kind of close. I don't know if that's for the views or not, but we want to get close without touching either the planet or the black hole. So as I walk through my code for this part, we see that the black hole has the mass that we got from our previous part. They could see the a few slides earlier. For the ship speed, this was completely random, up to me. It was trial and error. You're gonna see the results in the next slide. Those results, yeah, I just kept guessing numbers that worked here until I got something that I was satisfied with that got close to the black hole but didn't touch it. Here you can see all my calculations that I put in. Um, so radius from or vector from black hole to planet, blah blah blah. You can see the force on black hole or force the black hole has on the planet. Um, distance, airhead, force of the ship on the planet, and then F net on planet is force of black hole plus force of ship. And then as we move on to having the ship as our system, here our the planet was the system. Here our ship is. Um, yeah, you can see the distance calculated here and whatnot. Force. Yeah, so just kind of repeat the same process here. And then we can finally see our equations here for our planet velocity and planet position and ship velocity and ship position. Yeah, so here are our results. This magenta line is the trajectory of the ship, and then here's the planet. As you can see, I got very close to the black hole, but I didn't touch it. I did this so by having a really fast x velocity. That way I could escape, the gravitational force the black hole had on the spaceship. And I got, and with that really fast, like just, a little bit below speed of light, um, had the Y velocity get as close as I could, and then since it was so fast, again, it could just escape the gravitational pull. Now, say if I had a slower X velocity, the trajectory, well, first of all, it would have gotten caught up here, but it would look more rounded, something like this. If you could follow uh, this red thing, it would look something like that, kind of rounded and whatnot. But yeah, I just got super fast zip through. And yeah, so that's that. And here's the ship velocity and plant velocity, and yeah.